The second is that is the effect of temperature. Effect of temperature. As we know, that is V is under root of gamma pressure. It should be divided by the density, and according to the ideal gas, we have PV is equals to nRT. From here we get the value of pressure. Now put in 1. So what is 1? This is 1. So the value of which will come out nRT gamma density with volume, and you'll solve, and this becomes the total mass. It means the velocity is directly proportional. This is constant, so only the temperature under root. If V1, then temperature is V2, the temperature is T2. When we divide that V1 upon V2 is equals to under root of T1 upon T2. So this is the effect of temperature. Now the third is the effect of pressure. Same, the velocity is directly proportional to the pressure. Now the fourth is that is the effect of humidity, or we can say moisture. We are finding the effect of humidity or moisture on velocity. For this, let rho m is the density of moist air and rho d is the density of the dry air, and the velocity of the moist air, that is Vm, and the velocity of dry air, that is Vd. D stand for the dry, M stand for the moist. Now assume that gamma is same for the moist air and the dry air. So we have the formula for velocity, that is pressure gamma upon density. For the moist, so pressure gamma is the constant and the density for moist. Same for the dry, P gamma upon P dry. So Vm upon Vd, if we are going to find out, that becomes rho d upon rho m. So it is the relationship which is required. And the next is the fifth, that is the effect of frequency. It is important. There will be no effect on velocity due to the frequency. You have to keep in mind. Now we are going to find out a equation for simple harmonic, I will write down the complete, that is the simple harmonic traveling wave. For this we'll draw a diagram. Suppose this is the x direction, this is the amplitude A, this is the y direction, this is the starting point, this is from here to here, it is the wavelength lambda, or from this peak to this peak it is also the wavelength lambda. Let the velocity is v, and the phase are lagging by phi, and phi is equals to 2 pi x by lambda. So this is the wave, this is the amplitude, this is the direction, and in this direction the velocity is v. This is the peak to peak, for this is the wavelength, or the minimum to minimum, means complete one circle, it is the total time period. Now let a plane simple harmonic wave start from origin O and travels with a velocity v along the direction of x-axis according to the figure. Now from this graph, the displacement curve wave at any point, that is P. Let that is the point is here, that is the point P. We are just talking for this point. The displacement curve at any point P at time t, and the time period which we are taking, that is small. So the displacement, like that is y of the particle at O at any time t is given by equation, that is a sine of omega t, where y is the displacement, a is the amplitude, sine is the function, omega is the angular velocity, and t is the time period. So we can write y is the displacement, a is the amplitude, and omega is the angular velocity. Fine. Now, if phi is the phase leg of the particle at any point P with respect to the particle at O, then the displacement of this particle means which is at point P, at point P at the same time. What is the time? That is T, can be written as, what is the equation? That is the y. From here we are going to write down, that is a function is with the sign omega t minus of phi. So for a point P, what is the phi? That is 2 pi x by lambda. That is the phase difference. So we'll put it here. So y is equals to a sine of omega t minus 2 pi x by lambda. So a sine, we'll put the value of omega, that is 2 pi by t with small t, 2 pi x by lambda. From here 2 pi is to be taken common, so it is t by t minus x by lambda. From here what we are going, we are taking lambda common, so it is lambda t by t minus of x. So ultimate displacement equation will be a sine of 2 pi by lambda x by time period. It becomes the velocity with a function of time with the x. So this is the ultimate equation which is required. You can note that down. Now some important steps, that is the NTS means, note this step. What is the first one? When the wave is moving from right to left, this is the movement of that wave in opposite direction, then the phase will lead and the equation of the displacement of wave will be, that is y a sine 2 pi, that is t by t plus of x by lambda. So from here we can write 2 sine 2 pi by lambda, that becomes vt plus of x. The second, when left to right, that equation will be same, that is y sine a sine 2 pi t by t minus x by lambda, a sine 2 pi by lambda, that is equals to vt minus of x, that is the value of y. As the one form also we can write here, that is that is y is equals to a sine 2 pi t by t minus 2 pi lambda with x. From here we can write it is a sine, this becomes omega t minus it becomes k, where k is the coefficient of x, it is a constant. Now the next is superposition principle. When two or more waves passes through the same medium at same time, then the net displacement of any point is equal to the vector sum of their individual displacement at that point. Suppose that if y1, y2, y3 are the displacement at a point in a medium where n waves superimpose on each other, then the resultant displacement y can be written in the following form. That is the y, it is the total displacement, and we have the individual displacement y1, y2, y3, y4 and yn. So it is the sum total of the individual. This is the meaning of superposition. If I want to discuss with the diagram, so this is the one wave, this is the second wave, this is half, this is full. In this is the half and this is full. It is A in positive direction, it is A in negative direction. So this is A, this is B and this is resultant. So this A plus minus 0, it becomes 0 here. It is negative direction, my plus A, it is minus A, again a 0. So this will be the resultant. It is a superposition. The second diagram is here. This is second is this. So it is A, it is B, it is plus A. Suppose this is B, it is plus A. So it is the resultant value. This is the y is equals to A plus B. So it is the resultant. In the opposite direction, it will decrease. In the same direction, it will increase. Now, I'll discuss stationary wave, or we can say standing waves. The next topic is this. So for this we can write that when two progressive wave of same wavelength and amplitude travels with the same speed along the same straight line in the opposite direction, these waves interfere to produce a stationary wave or standing waves. In a standing or a stationary wave, the amplitude varies from place to place along the waves. Suppose if I'll draw a diagram for this stationary or the standing waves, so these are the nodes. The second is this one. So according to the figure, there are some points where the amplitude of the particle of the medium is 0, and these points are called the nodes and represented by the capital N. So at this point, amplitude 0, amplitude 0, amplitude 0. Now, according to the diagram, there are some points where the amplitude of the particles of the medium is maximum. These points are known or called antinodes, and it is represented by A. So these points A, this is A. At this point the value is maximum. So what about in between node and antinodes? So we can write in between the nodes and antinodes, the amplitude of the particle varies from 0 to maximum. From 0 to maximum. From maximum to 0, 0 to maximum, maximum to 0. And these waves are called the stationary waves because there is no transfer of energy along the wave. So what is the important things? Because there is no transfer of energy. What is the reason for this is no transfer of energy? The reason is the particle at the nodes do not move, so that the energy cannot be transformed across them. That's why the transfer of energy did not take place. Now the next is the formation of stationary waves, or you can say the graphical representation of stationary waves. This is the formation of stationary waves. This is the diagram for that. See, this is the diagram. This is the first phase, this is the second, this is the third, this is the fourth, this is the fifth. This is the one way with the amplitude of A1, it is moving. This is the first phase. Then this is the second phase. It will start from here. Again, it will start from here, but that is start from the backwards. Again, it is 0, it is maximum. And again, it will start with this. Same is here. This is the two waves. This is the time period, that is the t is equals to 0. This is the time period t by 4. This is the time period for the half cycle. This is 3 by 4 of the time period, and this is the total time period. Same direction, superposition principle, the amplitude will be increased in the same direction. Same is here, same is here. So at this point, what we are getting, minimum amplitude. These are the points where the amplitude is minimum. So these are called nodes. Same is here. 0, 0 nodes, 0, 0 nodes, nodes. In all directions or in the doll diagrams where you will get the amplitude is 0. This is the minus direction, this is the plus direction. It is the minus of A1, it is the minus of A2. So it is becomes 0. So these points are called the nodes. When it will get the maximum, that is the antinodes point. So this is the formation of the stationary waves. Now, some important steps which has to be remembered. It's the only one, that is the wave pattern as shown in figure this is A, this is B, and this is C. Figure C are called the standing waves because the pattern do not move. What does it mean? Means to say that the location of nodes and antinodes do not change. So for this reason, it is known as the formation of the stationary or the standing waves. Now, equation of stationary wave. We are going to find out the equation of stationary wave. For that, we will draw a diagram. This is the origin. Suppose this is A wave, this is B wave, this is the Y1, this is for the Y2. These are the nodes and these are the antinodes. This is, suppose this is A point, so this becomes antinodes. This is for the B, this is A, so this is sorry, it will start from here, it is not from here, it is from here. It is antinodes. So this figure, the displacement y1 of a progressive sinusoidal wave at any time t and at a distance x from the origin is given by the following equation. And what is that equation? That is the y1 a sine of omega t minus of kx. This is the standard equations where a is for the amplitude, omega is the angular velocity, k is the wave number which is 2 pi by lambda. So these are some standard values, and lambda is the wavelength of wave. Now the displacement of y2 of an identical wave which is traveling in opposite direction. This is, so this is the amplitude of this one. So this is the y2, it is a, amplitude is same, sinusoidal function, it is a sine, omega t, opposite direction means it becomes plus of kx. So we have two equations, this is for the upper one, this is for the lower one. Now if these two waves are superimposed, then the resultant displacement can be written with the applicability of the superposition principle. If the y is the total displacement, that is the superposition principle y1, y2, we'll put the value, that is a sine of omega t minus of kx plus a sine of omega t plus of kx. So here we use to solve this equation, that is sine c plus sine d. We have a trigonometric formula, and the expansion of this sine c plus sine d is equals to cos c minus d by 2 sine c plus d by 2. So this whole becomes c, this whole become d. We have this formula which is a trigonometrical formula, and this formula is to be used in this equation. So what we get, that is a is the common, that is the sine omega t minus of kx plus sine of omega t plus of kx. Now it is sine d, it is sine c. Now we'll apply this relationship. or the trigonometric functions. So it becomes 2 cos omega t minus of kx minus of omega t minus of kx divided by 2, and then the sine function, that is the omega t minus of kx first function plus omega t plus of kx, and it is to be divided by 2. What can we cancelled out? It will be cancelled out, omega t minus omega t plus, here the kx plus kx minus. So what we are getting here, it is 2 cos of minus 2 kx by 2. It becomes sine 2 omega t by 2. 2 is cancelled out. So it is 2a cos of minus of kx, and this is sine of omega t. Cos of minus theta, it becomes cos theta. So it becomes cos kx and sine of omega t, because cos of minus theta is equals to cos of theta. From here we are using here, and it is 2a cos of kx sine of omega t. So it is 2a sine theta cos theta. So it becomes 2a is the amplitude, which is sine of omega t. So it becomes the amplitude, that is 2a cos of kx, it becomes a sine of omega t. So we can write here that a is the amplitude of the resultant wave, and a is 2a cos of kx. So it becomes 2a cos, the value of k is equals to 2 pi by lambda with x, because you can write here k is equals to 2 pi by lambda. This value is to be put in place of k. So this is the amplitude. So now this equation can be concluded in the following 2-3 points. So we can write, so the conclusion of the above equation can be summarized under the following 3 points. What are these 3 points? The very first is, that is the each particle of the medium vibrate in simple harmonic motion with amplitude 2a cos of kx, which shows that the amplitude are not equal for all particles. So we can say that the amplitude depends on x. This is the first thing. The second, the position of O, the amplitude are the nodes, the amplitude which is a is equals to 2a cos of kx which is equals to, we can write that is 2a cos k is 2 pi by lambda with x is always 0 for those positions for which cos 2 pi by lambda x is equals to 0. So what does it mean? We can write where these values are 0, 2 pi lambda with x is equals to n pi by 2, where n stands for 1, 3, 5, 7 and so on. For these values, the value is 0, means at these points there will be the existence of the nodes. The next, so for nodes, the value of x is equals to lambda by 4, 3 lambda by 4, 5 lambda by 4 and so on. The next point, that is antinodes, are those points for which the amplitude has its maximum value, means the amplitude A is the value it's 2a. What does it mean? It means cos of 2 pi by lambda with x is equals to either plus or minus 1. So it will be m of pi. So 2 pi by lambda with x is equals to m pi, where m is equals to 0, 1, 2, 3 and so on. Which means the antinodes will be x is equals to 0, x is equals to lambda by 2, x is equals to lambda and so on. Means two consecutive antinodes will have a difference of lambda by 2 wavelengths. We have taken as a assumption, what is that assumption? That the reference origin is with antinodes. Just see the diagram. In the starting, what we have taken? We have taken in the starting, this is the antinodes. So with these references, we are calculating all these things.